In this video, we are going to discuss how to calculate acceleration from velocity time graph. So here you have a velocity versus time graph where velocity is on the y-axis and time will be on the x-axis. Average acceleration is given by the rule v final minus v initial over t final minus t initial. So to calculate average acceleration, I will have to find the final and initial values of velocity and time. If the graph is just a straight line, you can also calculate this acceleration by just taking the slope of the graph. Slope of the graph is given as y2 minus y1 over x2 minus x1. So you choose any 2 points on the graph and then take the slope from it only if it's just a straight line. Otherwise, we stick to the rule v final minus v initial over t final minus t initial. So let's see how do we apply this rule. To apply this rule, I need the final and initial point. So initial point is the starting point from where we begin our motion. So this is the starting point here. I call this initial I. So let's write down what is the time and velocity value here. Velocity is on the y-axis. So this value becomes my initial velocity. So I write v initial to be equal to 150. For time, you have to go down to the time axis, the x-axis. So here we reach the origin. The value here is 0. So initial time will be 0. Then we look at the final point. See where the graph ends. It's over here. This is the final value. So I write this as final f. Look at the time value here. So time value here is on the x-axis, which is 30. So I write final time to be 30. And then velocity value you can get by going to the y-axis. Go to the y-axis, you reach the origin. Value at origin is 0. So v final will be 0. Now we can put these values in the rule. I write the rule again. Average acceleration is v final minus v initial over t final minus t initial, which is equal to final velocity here is 0. Initial velocity is 150, so minus 150 over t final. T final is 30 minus t initial is 0. When you put this in the calculator, you get the answer to be minus 5 meter per second squared. Meter per second squared is the unit of acceleration. You need to write with all the values. Minus sign here represents the direction. Acceleration here is negative. Next question. Refer to the figure to find average acceleration of the train during the following time intervals. So we have 3 time intervals here and we need to find average acceleration for each of them. So let's start with part A, where time t is from 0 to 5 seconds. So t equals 0 is right here at the origin. I will call this as my initial point. T equals 5 seconds will be in between 0 and 10. So this is 5. Where the graph reach at 5 seconds, we will take that as the final point. So let's write down the velocity and time values here. Initial velocity here will be 0 since we are beginning at the origin. All values at the origin is equal to 0. Initial time will also be 0. Final time is at 5 seconds. And at final time, I need to find the velocity value. So go to 5 seconds and see what is velocity on the y-axis here, which is 10. After this, we write the rule. Acceleration is v final minus v initial over t final minus t initial. So final velocity is 10, initial is 0, final time is 5, initial is 0. That gives you acceleration as 2 meter per second squared. Then we do the same thing for part B, where we find average acceleration from 15 seconds to 20 seconds. So 15 and 20 will be your initial and final values. So let's find 15 seconds on the graph. It will be between 10 and 20 right here. Wherever the graph is at 15 seconds, that will be your initial point. I write this as I. And then 20 is here. Wherever the graph is at 20, that is your final. So we write V initial and V final. V initial will be at initial point, go to the y-axis and see what number do you have here. It's 10 again. So V initial is 10. T initial is the initial time, which is 15. V final is go to the final point and move along y-axis to see the velocity value here. So final velocity is 4. Final time will be 20. Now let's substitute this in the equation. So we write acceleration A to be V final minus V initial over T final minus T initial, which is equal to V final is 4, V initial is 10, T final is 20, and T initial is 15. And when you solve this, you get acceleration as minus 6 over 5, which is negative 1.2 meter per second squared. Now let's look at the last one, where we find acceleration from t equals 0 to 40 seconds. So t equals 0 is over here. So this will become my initial. Initial point is at the origin. And at the origin, all values are 0. So initial velocity will be 0. Initial time will also be 0. T final is at 40 seconds. So this is my final value. So T final will be 40. V final will be equal to, at 40 seconds, what is the velocity value? Go along the y-axis. It is 0 again. So V final is 0. So we write acceleration A equals V final minus V initial over T final minus T initial, which is equal to V final is 0, V initial is also 0, T final 40, and this is 0. That gives me acceleration as 0 meter per second squared. Now let's try another similar question. Refer to figure to find acceleration of the moving object at each of the following times. So we need to find average acceleration for part A to D. Let's start with part A. In part A, we need to find acceleration during the first 5 seconds of travel. First 5 seconds means starting from 0 and going until 5 seconds. So this is 0 right here. I'll call this as my initial point. 5 seconds over here will be final point. So let's write down velocity and time values for this point. V initial and T initial, since they are both starting at origin, their values will be 0. T final is at 5 seconds. V final will be at 5 seconds. Go to the graph, move along y-axis. Whatever number is here, that is your V final, which is 30. Acceleration A is V final minus V initial over T final minus T initial, which is equal to V final is 30, V initial is 0 over T final 5 minus 0, which will be 6 meter per second squared. Then in part B, we have to find acceleration between 5 seconds to 10 seconds. So 5 seconds to 10 seconds lies over here on the graph. So this will be my initial and this will be final. So let's write down the values of velocity and time. Initial time is 5 seconds. Initial velocity will be go along y-axis. This is initial velocity 30. Final time is 10 seconds. And final velocity at 10 seconds again go along y-axis. See the value 30. Acceleration A will be V final minus V initial over T final minus T initial, which is 30 minus 30 over 10 minus 5. That gives you acceleration as 0. So whenever in velocity time graph, you find a straight line parallel to time axis like this one over here. In this situation, your acceleration will be equal to 0 because here velocity is constant. It's not changing. Then we go to part C where we find average acceleration between 10 to 15 seconds. So 10 seconds is right over here. I call this as initial. The starting time will be initial. The ending time will be final. So 15 seconds here is final. So we write initial time to be 10, final time to be 15. Initial velocity will be whatever is the velocity value at point initial. So go along y-axis. This is initial velocity. Final velocity will be go to the final point, move along the y-axis. Whatever number is here is your final velocity. Now substitute acceleration A is V final minus V initial, T final minus T initial, which is 20 minus 30 over 15 minus 10. That gives me acceleration as minus 10 over 5, which is negative 2 meter per second squared. And then we do part D. We have to go from 20 to 25. So 22nd is here, so this becomes my initial. 25 is here, so this becomes final. So initial time is 20. Final time is 25. Initial velocity will be, let's go to the initial point, go to y-axis, see what is velocity value. That becomes your initial velocity, which is 20. Final velocity will be, go to the final point, move to y-axis. Here we are coming at origin. So at origin, all values are 0. So final velocity will be 0. So acceleration A is V final minus V initial. T final minus T initial, which is 0 minus 20 over 25 minus 20. That gives you negative 20 over 5, which is negative 4 meter per second squared.